Hi, my name is Alex Norton. I'm an analyst with Hyperion Research, and today we'll be talking about HPC in the cloud. Give me 1 second to pull up my slides. So to start, let's begin at the forecast. This is our updated 2020 HPC cloud forecast. This forecast does include the impact of the COVID-19 pandemic. If you have not seen this forecast before, this is from the perspective of what end users spend on cloud resources. So this is not what CSPs are buying in hardware, but rather what a user spends with a third-party cloud provider. Based on new data over the course of the year, our updated forecast projects out to 2024 that the market will be just under $9 billion of end user spend at a CAGR of 17.6%. which is more than 2.5 times larger than the on-prem CAGR. One thing we've seen from the COVID-19 pandemic is that we anticipate cloud usage to actually grow in the wake of the pandemic, contrary to other areas of the HPC market, which have seen declines. This graphic shows what the 2024 forecast for the HPC broader market looks like if you add cloud in. Right now, cloud brings the 2024 total spend to $47 billion, with cloud spend making up about 8.8 billion of that, which is the second largest category behind server spend. What we want to show here is that there's a hypothetical growth point or growth year that may occur in the forecast period. On the screen right now is our 2019 and 2020 forecasts in gray and orange respectively. And what we want to show is a hypothetical growth year occurring in the 2021 to 2022 timeframe. Now this blue line shows a theoretical movement of the market, but we anticipate over the forecast period to have a major growth year. Much of this growth we anticipate being driven by the dramatic additional improvement of running hard HPC jobs on the cloud, a sizable improvement in the ease of use and ease of deployment of HPC applications in the cloud. And what we mean by this is limited to no alterations to the code to be able to run it on the cloud versus on-prem. We also expect that if there is more cost effectiveness to running in the cloud and more cost transparency for running jobs in the cloud, that this may push more users to take advantage of the cloud. And then finally, as AI continues to grow in utilization across the HPC ecosystem, we expect a number of users to move more of their applications to the cloud in the AI space. This chart breaks out the cloud forecast by the 13 verticals that we track. As you can see, biosciences and manufacturing, or here listed as CAE, were the two early adopters of cloud and represent the large portion of the overall cloud market from a spend perspective. We are expecting high growth from the EDA, geosciences or oil and gas, and the academic sector over the forecast period. What this graphic shows is the difference between the vertical spending on-prem and in the cloud. As I just mentioned, biosciences and manufacturing make up a large portion of the on-prem spend, but do not make up the same large portion of the cloud spend. That belongs to the government lab and academic sectors, which represent over 30% of the on-prem market, but only 12% of the cloud market. One of the things that has come out of our research in the past year is more information about the work group. Now, these are users who are buying systems at less than $100,000, and following the 2008 recession, this market never really recovered to its normal or the growth rate of the rest of the market. And new data has shown us that part of the reason that this group has not rebounded is that they've actually shifted to running more workloads and spending more money in the cloud. The value proposition of the cloud, especially in the wake of COVID-19, is so much greater for these users to have the ability to turn their resources on and off and scale up and down on a moment's notice as the world changes. I want to touch on just a couple of the potential drivers for major increased cloud usage over the next few years. One is a new take on cost effectiveness. Cost traditionally was seen as just the dollar amount on a bill and has always been an issue for users when they're assessing the cloud. But new data suggests that users are looking at the cost effectiveness of the cloud and they are incorporating new portions of running a workload to that. So this includes looking at queue times, which can be very long on-prem and are non-existent in the cloud. Looking at the variety of hardware available on the cloud that may not be driving users to look at the cloud more. And then finally, the cloud allows for a scaling that may not be capable on-prem. And these are three of the factors that are now being incorporated into a cost effectiveness analysis for HPC workloads. We've also seen across the HPC ecosystem that AI continues to grow in adoption and utilization, and the same is true for the cloud market. Recent data suggests that the average or traditional HPC user is anticipating to run about 20% of their HPC-enabled AI workloads in the cloud in the next year. Part of this increase is due mainly to access to a variety of hardware and software geared towards AI applications, and also access to data that is either stored or collected in the cloud. This includes public data sets as well as IoT and sensor data that is collected and stored on a cloud platform. Thank you so much for listening to me today. If you have any questions about anything, please feel free to email us, and we are happy to answer any questions. This was just one snapshot of a lot of research that we've been doing on the cloud in the last year. Thank you.